Okay, good Friday to everybody. Thanks for joining me for the WARDCAM webinar. So the idea of this is to run through basics of WARDCAM. So some of you may already have WARDCAM. Some of you just might be interested in its capabilities. So I'm going to run through what it can do. So we've got two different versions of WARDCAM up on my screen right now. So on the left is the legacy version of WARDCAM, and then on the right is a newer version of WARDCAM that we just started shipping this year that we call the midnight version. So on the left is the daylight version, and the right's the midnight version. So I'm going to be focusing on the midnight version. Only a couple slight differences between the two. Midnight version, you have the easy option to change between imperial and metric down here in the lower right-hand corner just by clicking on this button. Whereas before in the prior version of WARDCAM, if you wanted to change, you would have to press the scroll lock key on your keyboard and then go into global settings, which would open up a window like this, and then you had an option down here to switch between imperial and metric. So that's one difference. The other difference is that we do now have a simple shape library in this version. So if you click on this, open up a little window, it shows you some basic patterns that you can choose and plug in the different dimensions to quickly create parts that way. So those are pretty much the two differences between the old version and the new version of WARDCAM. I guess one other difference is that the old version of WARDCAM required a USB security dongle to be plugged into the computer. The newer version of WARDCAM just requires somebody from WARDJet logging onto your computer and activating WARDCAM. So I think that's it. So I'm going to close out the old version for now, and we'll focus on the new version here. So when you first open it up, simple screen like this, and you can obviously, like I showed you, go into the shape library, choose a part that way. Or if you've got a DXF file, click on the open button and then navigate to wherever your file is. And I guess that is one other thing, is that newer version of WARDCAM does also support DWG files, where older version of WARDCAM was just DXF. Now we can do either DXF or DWG. So that's a nice new thing here. So I'm just gonna, you can either click on the file and click on open down here, or just double click on the file and this will open it up. So, and WARDCAM is designed to be just a basic CAM system where it's gonna create the your G code for your machine. It's not designed to be a CAD system. We assume nowadays that most people already have CAD, so there's no real CAD capabilities built into WARDCAM. On the left, there are some editing tools that you can use, some tools to modify a file if you need to, or clean up a file, but there's no real CAD that's built into WARDCAM. So a file like this, this has come in, it's got some extra data on here. Right now, top left corner, I have my select tool activated, so you can either select things and delete things. And if you watched last week in iGEMS, or if you're familiar with CAD, if you left click and drag a box from left to right, it's going to select everything that's within that box. So it has to be entirely within the box to select that. If you drag from right to left, it'll select everything that's crossing and within that box. And then if you select something and you want to deselect something, you can just hold down on your control key, and you can use similar tools to deselect things if you select too many things. So I can go through and, as I said, delete things that way. This one up here on the top left-hand corner, we've got a layers box here. So if this was drawn with layers, you can come through and you can turn off different layers. So right now this drawing has 3 layers in it. 0 layer, dimension layer, and a title block layer. There's these little eyeballs next to these layers. If you click on the eyeball next to the layer, it'll hide that layer. So you have to click on the eyeball will come shaded out, and then when you click out of that box there, that layer will then be hidden. And if I click on the eyeball next to the title block layer and then click out of here, that layer is hidden. So right now we're only seeing the 0 layer. And one thing that I will caution you about, if you turn off a layer and you mistakenly go to that layer, so if I, for example, I've hidden my title block layer, but I've also, now that I've clicked on the title block layer, I'm on that layer. If I then try to do something like I copy this geometry and I move it up, even though I'm left clicking and that part should be copied, we're not seeing anything. And that's because, unbeknownst to me, I changed myself onto a layer which is currently hidden. So if I come up here again, turn on that title block layer, then we'll see those copies that I made there. So you do have to be a little bit careful about that. Fortunately, there is this undo button here. So you got undo and redo buttons up here. So if you do make a mistake, you can backtrack a bit there. All right, so we're going to turn that title block layer off, and we're going to switch back to our 0 layer. And again, I've got this over here. I don't want to cut. I'm just going to select and delete that. Scroll wheel, you got your middle scroll wheel. So if you do have a middle scroll wheel on your mouse, you can roll that in and out, zoom in and out. If you're zoomed way in or zoomed way out, if you double click your scroll wheel, it'll zoom extents. So if you don't know where you are, just double click your scroll wheel and it'll fill up the screen with your geometry. So run through some of these editing tools over here on the left. Let's say in this little notch area here, I actually wanted this line to go straight across here. I want to get rid of that little notch. I could take it back to CAD, of course, and bring it back in, but I can do some cleanup things over here. Right now, since when I click on this outside geometry, it selects the entire geometry. Right now, this is all joined together as one polyline. So down here, about halfway down, we have this explode option. So if I click on this, then it'll break that up into its individual line segments. Now, since I'm still on the explode command here, if I hit escape, it's always going to bring you back to the select tool being active. And then at this point, I could select those little lines in there and just hit the delete key on my keyboard. Or if I select those, there is also a delete button over here. Or you can press D on your keyboard also. And then to close up that gap, there's a line command. And as I hover near the end of one of these lines, you'll see that little blue box shows up there. That's a snap point. So as long as I click when that blue box is showing, then that's going to put the line right at the end of that existing line. And then if I move over to this other line, that blue box shows up. As long as I left click when that blue box is showing, then that line will be connected with the other line there. So, see, we have a rectangle box here. I'll talk about that one some more later. You've got options to draw points. Sometimes maybe you might just want to do a pierce in a certain location on a part because you're going to drill it out later because maybe it's too tight of a tolerance, too tight to WaterJet cut. You can use this point command and you can draw a point at things like centers of circles and such, and then we can pick up on those points later to add different tools passed to those things. So if I put a point, say at the center of this circle and the center of that circle, we're going to tell it that we're going to pierce those later. And in that case, we're actually not going to cut these holes because we're just going to ream those out on off the machine. Delete, we talked about trim. So trim works just like in CAD if you're familiar with that. So if you've got 2 lines and you can just use the scissors and you can click on the segment of the line that you want to get rid of and it'll trim it up like that. So it's a handy cleanup tool. And we'll get rid of that. And then down here, you've got different options for moving and copying, rotating, scaling, mirroring. So scale command is handy if a file comes in that was drawn in metric. You want to scale it down to imperial versus switching your whole system over to metric. So if we did want to scale this part down, for example, since my select tool is on, I can just drag a box around this, click on my select tool, and down here at the bottom, it prompts me to select base point for scale. So I'm just going to click. Doesn't really matter where I click, just somewhere near the middle. And then down here at the bottom, it says select scale point or use keyboard input. So if I am scaling this from metric to inch, I would just start typing 0.03937, and that would scale that down appropriately from millimeters to inch. Now, this file was actually drawn in inch, so I'm just going to undo that. So that's how that command works. And I'll double click to zoom extents again. And then let's see. So also down here, we've got things like the copy command. So if I go ahead and I select this, and I want to make a couple copies of this, once I've got it selected, I can use my copy command. And down here at the bottom, it says select base point for copy. So I'm just going to left click wherever, and I can drag this up right now. I can move this in any direction I want. There is also this ortho button up here. If I turn on ortho mode, then you can only go in your 90-degree increments. So if I want to make sure that I copy this straight up, I can turn on my ortho and bring that straight up. And then I might want to spin this part around. So again, I can select what I want to work with, and then I can use my rotate command. And again, I'm just going to approximately click in the middle here. And again, down at the bottom, select rotation point or use keyboard for input. So if I wanted to rotate it 30 degrees, I could type in that. Since I have my ortho button turned on, as I move my mouse around, it's going to snap to the different 90-degree rotation points. So we're going to rotate it like that. And then since this has remained selected, I could then use my move command. And again, I can just click wherever, and then I can drag this down here and get it fairly close to the other part. And since when I rotated it moved a little bit, I can turn the ortho off and try to line it up here visually. There's no measure tool in here, so all I can do is visually look at things to determine how straight they are lined up here. Also down here in the lower left-hand corner, you got your XY coordinates. So if I want to get an idea what sort of gap that I've given myself here, if I look at the Y coordinate when I'm hovered over this corner, we see here that we're about 159.7, and up here we're at about 159.86, so it's about 1.16 or so gap width that I've got there. Once you've got your geometry the way that you like it, you can top right-hand corner, we just hit the next button, goes to the next step in the process. So right now we're on the geometry step. Click on the next button, and it brings me into the parts area. And 99% of the time when you're in here, about the only thing you're going to do is you're going to click on your machine and select your material and thickness that you're doing this out of. So if we're going to do this out of aluminum 1/4 inch, you can go ahead and select those. And earlier we put these little points in here where we were just going to do pierces. So this is a situation where you would actually do something in the screen other than just picking the material and the thickness. So over here on the right, you've got different things that you can do with what we call open contours. So if you've got a line you want to cut as a slit, points you want to pierce, that's where these commands over here on the right can be used. So we can do things like mark if we want to just etch something. If we want to cut a slit in a part, we can use the open contour cutting. Point functions can be used for doing things like piercing with the WaterJet. If you have a drill on your machine, you can drill your pierce points, or if you just want to go to a location and stop, you can insert a stop, which would put an M00 into your file, and machine would stop at that location until the operator hit continue. So in this case here, we're going to do abrasive pierces. So then once I've activated that tool over here, you'll see as I move my mouse towards these open contours here, it'll snap a line to those. So if I want to pierce this one first, I can just go around and click on those 4 points there, and you see that we've added those, start adding these to our cut order up here. And this little box here is you can resize this as you get more cuts in here. Basically, as you move your mouse towards the border here, we'll be able to resize that later. Then we'll talk here in a little bit about how we make new materials and machines and things like that. So we'll go ahead and hit our next button. And this brings us to our toolpath area. In its simplest form, top left-hand corner, you can click on the auto button, and it's going to add your toolpath to the part. So up here again in the left, we've got our cut sequence. So we've got the 4 pierces that we programmed in the prior step, and then we've got our cut sequence for the other geometries. So WARDCAM always does a nice job of recognizing inside and outside holes. So it's going to do the inside slots first on this part, and then do the outside cut, and then the inside slots on there, and then the outside cut. If you want to reorder things for whatever reason, up here, just pick whatever cut you want to reorder, and you've got your arrows here, and you can move these up or down in your cut sequence. So if we wanted to maybe do all the inside cuts and then cut the 2 outside on this one here, we could go to the outside cut and just move that down in our cut sequence. But I'm going to put that back where it was. So, other things you can do down here is you can change lead position very easily. So WARDCAM does a nice job of trying to always move away from where it finished cutting to go to the next geometry it's going to cut to avoid tipping, crossing across parts that have tipped up. So if you don't like where WARDCAM put the lead in, you can always click and move the lead in position. So you just move your mouse and then just left click and change your lead position. So the outside cut, we can move this down here somewhere. This one over here, because of the gap between the parts there, put our lead there, but we can just move that out here somewhere. And of course that was too close there because of the length of the lead and the gap between my parts. If I try to click and put the lead there, it gives me a message that it can't put the lead there because that gap is too small based on the length of the lead that I've told it. Other things you can do in here is you can change the quality of different cuts. So if these inside slots, I want to cut those at a slower speed. Up here in my cut order box, if I want to select multiple cuts at one time, you'll see as I click on these, it highlights which one it's working with. So if I hold down my control key, I can select those 4 inside slots, and I can come down here and I can choose a different speed, which will affect my edge quality and my tolerances. So if I want those to be nice and smooth, click on that, and then the color changes as we change the quality. And you can also do a similar thing for just a portion of a cut. We have this tool down here for partial qualities. If I expand this one here, again, I can choose a different quality. Maybe this time I'll do smooth. And maybe in this little notch area here, I want to cut this a little bit slower. I can basically just left click 2 points around that area and then left click again to lock it in. And then that area will be cut slower than the rest of the part. And I can do a similar thing down here. So those are the basic tools that we have in the screen here. I will show you here briefly as if we did want to change length of leads. So maybe I really wanted to force my outside lead to be in this area here, but this lead's a little bit too long. If I click on this Edit Leads button, it'll bring me into my material database, which we'll talk about a little bit more here in a bit. But basically right now it brings me to my 1/4-inch aluminum that I'm working on, and we've got multiple tabs in your material database, one for feed rates. So these are the speeds that it's going to do based on the different qualities that we've selected. And then you've got the leads tab here. So in the leads tab, you can define things like length of your inside lead in, length of your outside lead in, and then this other column here is always confusing when you first start using WARDCAM. This is for any geometries that are too small, where if it tries to use this inside lead of 0.2 and you've got a hole that's maybe 1/8 inch diameter, that's going to be too long for that hole, then it's going to try to use whatever is in this other column. I will tell you that by default, when you first install WARDCAM, these others are always set to 0.2. So I like to go through and set these all to something shorter like 0.1 or 0.12. So that way at least gives WARDCAM a fighting chance if you are dealing with a part that's got smaller holes, where it'll look at that other column and try to use that length of a lead in if this one fails. Those are the inside and the outside. The one we were talking about was the other. So right now the outside lead is set to 0.2, and I can drop that down to something like 0.12 and then click on Save and Exit, and then I can see if I can click in here if it's going to add my lead in there, which it did. So that's how you can adjust your different lead lengths. Now, since I had changed my quality, it also changed the outside quality there, but I can go through and change that and reapply that. So, and if I wanted this one down here also, I could do that. And then I'd probably want to change, anytime you start manually changing lead positions, you always want to make sure that you're not putting yourself into an area where you might get a collision. So if it finished cutting this slot here, if that slug tips up, I might cross right across there. So I can just move my mouse down again and just change that lead position. And by the by, if any of you ever have any questions as we're going through this, feel free to type them into the chat box when we get to the end. If there's any questions, I'll try to go through them. If you want to talk about anything offline, I'm usually available. You can email support@wardjet.com also. So let's see, we've got our toolpath pretty well defined here. So let's go ahead and, again, top right-hand corner, hit your next button, brings us to the final step in the process where we actually create our CNC file, the post screen. Over here in top right, you have an option where you can change your start point. So right now, we would be setting our nozzle in the lower right-hand corner of where we want to cut these parts, and then the cutting head would traverse up, cut that, pierce that hole, pierce that, and then work its way around like that. If you did want to change your start point to a different location, there are these snap buttons that you can turn on and off. So right now, for example, if I just leave the part bounds box on, as I hover near the perimeter of the bound of the parts, you'll see that little gray box shows up, and again, there's a little blue snap point that shows up there. I can just left click and I can move my start point to any point like that. Or for some reason you wanted it at the center of a circle, you can turn on center snap point, and then again, when we hover near the arc, it'll show me where the center of that circle is, and then I can click and change my start point to there. So sometimes that's handy if you're cutting a part out of a fixture or something like that. You can change your start point accordingly. So most of the time what you'll do in here, top left-hand corner, just click on the CNC button, and it'll send you to whatever your last location was that you saved the CNC file. It gives you a chance to rename it, all that good stuff. And if you have the option turned on, it'll automatically open up your CNC files. So some people like to look through their CNC files before they actually send them out to the machine, just to look for any strange things that might be in here. But basically, as we go through here, you've got your basic G codes for your rapid moves with XY commands, and M60 is our water on command, M70 is our abrasive on command. This one here just being the pierce, we've got basically does a second delay, and then turns abrasive off, turns water off, and then a half-second delay, and then we'll rapid to the next point and repeat that. And then when we get to actually cutting those slots, similar type thing, turn the water and the abrasive on. We have this G41, which is a tool offset command. We are offsetting for the diameter of our tool. If you want to add additional tool offset at our controller, that's why this G41 is in here. So as the nozzle starts to wear at our controller, you can add additional tool offset, and then this G41 tells the controller which side of these lines to add that additional tool offset to. And then on these, you'll see G01 is a straight line move, again, XY, and then we have our feed rates. So this is the feed rate that it's starting at, and then feed rate will ramp up and down as it goes through the geometry as it comes to corners and things like that. So that's what the CNC file looks like. And after you've created the CNC file, then you can also create a report. So click on the report button, and again, we'll just save that there and drag this over. So this is the report that WARDCAM can generate. So it gives you information about the name of the file, where it's been saved, a little image of the file, gives you an idea of the size of it, material and thickness, nozzle orifice combination that it was programmed for, little box here that you can type notes into, estimated time here, and then we do also, for our controllers, offer a barcode scanner where you could scan that barcode and it would go to a location on either the computer or your network and pull up that CNC file. So that's the report. So those are the basic steps to go through a file. And now we'll talk about some other features that are in here. So let me just go ahead and open up another file here. So once I open up another file, if I didn't close the other file, you'll see down here at the bottom, we've got tabs. So you can be working on multiple files at the same time and just click on the tab and toggle back and forth between the different tabs there. And this one here, we've also got some layers. So again, I'm going to click on these eyeballs on the dim and the title block layer, turn those layers off. So I've got my part, and top right-hand corner, just hit my next button. And let's go back to doing this out of, let's say we want to do this one out of aluminum, and we're going to do this one out of 1/8 inch. Hit my next button, click on the auto button, and voila. So you'll see here that we don't have a toolpath on these 3 holes here, and this is what I was talking about before on the length of these lead-ins on these holes here. So these holes, if I hover my mouse here, it looks to be about negative 4.926 in X, and so it's probably about 2/10 or 1/4 inch diameter hole there. And if I click on this edit leads box again to bring us back into our material database, again for this aluminum 1/8 inch thick, the other, again by default, is set to 0.2. So if I drop that down again to 0.12, save and exit, brings us back here, click on the auto button, and now it can put the leads on those holes. And then from there, it's pretty straightforward. And in fact, top right hand corner, there's this fast forward button. So if you get to a location in a program working through the steps here, you know everything's going to be the same as the last part. You can just click on this fast forward button and it'll go ahead and create the CNC file and create the report. So there's that one. All right, let's go ahead and take a look at this next one here. All right, so this one comes in, we've got no layers, no extraneous information, looks good. Top right hand corner, hit my next button, and got something going on here with this one. Normally we would expect to see that outside geometry be green like this, showing that it's a closed geometry, but it's gray, and we've also got this point up here. So if I hover my mouse right over that point and I use my scroll wheel, I zoom in and get real close on this, I can see that there's a little line segment here. So little residue from the CAD drafting. So if I go back without zooming out, because if I zoom out, then I kind of lose where that was. I just click on the geometry button, brings me back to here, and I can try different tools to clean that up. Now, first time I did this part ever, I thought, well, I'll use my trim command because that line is probably extended past there. So click on my scissors, and then I try to click on that little line segment and it won't go away because actually it's not connected to this other line. It's its own little individual line segment there. So if I click on the delete tool instead, I can then click on that line. Sometimes easier way to do that, use your select tool and then just drag a box around it, highlights it, and then you can delete it. So now we would go ahead and hit our next button, and now that's all green, so that's good. And then again, I would pick my material and thickness. So let's delve a little bit up into the machine and the material database at this point. So haven't really talked about the machine yet. So up here, you hit on your down arrow and you can choose from different machines. So normally when you first get WARDCAM, there might be 4 different machines in here, but of course I've added on different machines for different situations. So right now we've got the 2D machine and we're using a 1030 nozzle combination. Up here on database, if I click on database and then click on machine database, it'll bring me into my machine database and shows me all of my different machines. So if there's a machine in here I don't want to use anymore, I can just highlight it and click on remove and get rid of it. If I want to create a new machine, so actually let me get rid of one of these machines here so we can get rid of those. All right, so let's say right now this is set up for basically a 30 horsepower pump, 1030 nozzle combination. Really, I've got, let's say, a 50 horsepower pump and I want to be able to use a 1440 nozzle combination. This area here allows you to set up a new machine and tell it the information that goes along with that. So what I can do is find a machine that's similar to what I want to use and click on add machine. And when I do that, it's going to make a machine up here in the list called new X series 2D 1030. And then what you can do is just go in here and you can rename it. So we want to call this 1440. All right, so that's just a name. You can just name it whatever you want. This is not a water only machine. If it were, if you toggle this water only button on, then things like your nozzle size and your abrasive amount and things like that go away. So for abrasive machine, of course, you leave that on. If this were a 5-axis machine, you could toggle that on, and then it will put A and C codes in your 5-axis code. But we're just doing a 2D machine here. And then you've got settings for your nozzle diameter. So max nozzle diameter is the largest that you're going to want to let your abrasive nozzle grow to. And WARDCAM basically will look at geometries and figure out how far into tight geometries it can get before it's going to start digging into the part based on whatever number that you tell it here. So normally you'll set this to a couple thou above whatever the nominal size of your nozzle is. And then the nominal size of my abrasive nozzle, 40 thou. Pump power really doesn't do anything, but we'll just type in 50 anyways because it looks good. Max cut velocity. For most abrasive applications, we'll recommend setting this to maybe 80 or 100 because realistically, even on super thin material, you're usually not actually going to be able to get much above 100 inches a minute anyways. Sometimes people are cutting very thin material, 20, 30 thou thick. And if you look at the speeds that any feed rate calculator is going to start to tell you when you get to materials that are that thin, they're really not that realistic. So say we're doing something like 025 stainless, and we'll just stick with the 1030 nozzle combination. Any feed rate calculator is going to give you theoretical speeds like this, which are just not practical. Just based on the actual energy loss that goes into the tank when you're cutting super thin stuff. Now these calculators get much more accurate as you get thicker. So a lot of times what we'll do is if we have anything that's thinner than 16 gauge, we'll just program it for 16 gauge and go with that. So and then over here you got your abrasive flow, so just that based on your how much actual abrasive you got going to your cutting head. The orifice that you're using, so we're going to change that to 14, and we're going to change this to 1.4. Pump pressure, so what pressure you're actually cutting at. So if you are running your pump at a little bit lower pressure, you can type something different in there. So, but we'll go with 60,000 psi. And then max velocity, this would be the maximum traverse speed of the machine, which for WARDJet, most of our Z's, E's, and such are set to 500 inches a minute. And then down here, you've got information as far as where the post-processor is located that it's using, variables that it's using, that it's putting into the G&M codes, where the report file is coming from and such. And then down here, copy from. So since we're making a new machine, we can copy materials from an existing machine. So I can hit this little down button here, and I can tell it to copy materials into this new machine, and I can copy it from we'll copy it from this 1030 machine that we're just using. Click on copy materials, and it gives me a message that it finished copying those materials. So now I've got this machine pretty well set up. There's this advanced button down here. If this is turned on, then you can tell it where you want your default start point to be. So our older machines, we always put our start point lower right. Newer machines now we're starting lower left, so you can just click on this image and it'll toggle around to the 4 different options of where you can put your start points for your programs. And then usually for the endpoint, we usually set that at the opposite corner, and then WARDCAM, when it's going through its algorithm to add its leads, will kind of work backwards from the endpoint back to the start point. Now, if you've got multiple people that are programming off of WARDCAM, you can change where it's going to pull information like the post processor and these post variables from. So by default, WARDCAM is looking at the local C drive. But if you click on this choose file button, you can go through and you can copy these files onto a network drive location and have everybody point to the same network drive location, so you don't end up with 2 or 3 people working off of multiple databases and different machine settings and such. So you would do that for both that post variables area, this main.py file, and this variables.py file. If you need any help with that anytime, give me a call and we can walk you through that. So let's see, we've got that machine set up, and we'll go ahead and click on save and exit. The question came across, will editing your leads tabs require editing during every single part created, or can you save the settings you use for the specific material thickness? Yes, if you change your settings on any of those materials, so if we go back to that 1/8" aluminum that I did on the previous part, and we go back up into our database, material database, we'll see if we go back to the leads tab that it will have saved whatever I changed for the different lead lengths and things like that. If we look at the 1/4" aluminum that I did before, it's still got the outside lead length of 0.1 and that. So it does save whatever you change these to. And then this the tab width gets saved. So also you can do things like you can make multiple copies of the same material. So it's a good time to talk about the material database here some more. So we looked at this leads area before. If I want to make a copy of this, say 1/4" aluminum, I can click on Add Material, and like in the material database, it'll make a copy of that. So now you'll see I have 2 1/4" aluminums, and over here in this name box, I can rename one of them. So if I know that maybe there's a lot of 1/4" aluminum parts that I cut and I don't need any tab, I could rename this one like aluminum no tab or something like that, and then set this one to 0, and maybe it's a standard lead-in length, whatever, and click on Save and Exit. And then up here in my database pull down, now I've got the choice between aluminum no tab, and right now that's the only one that I've got with that name and that thickness. So you can go through and be creative with how you name your different materials if you do want to have flexibility to easily change between things like tabs and no tabs or length of lead-ins and things like that. So that's how you can make a new material. And I'll show you here briefly, if we go back to this basic 1/4" aluminum that I was looking at before. Right now, these are the feed rates that WARDCAM has generated based on the pressure settings and nozzle orifice and things like that. Now this is for the 1030, and if I come down here, I can switch to that new 1440 machine. So you'll see right now we're at 30.8 with the 1030 machine. If I switch to that new 1440 machine that I just made, let's see, there it is. So because of the upper limit that I put on things, I'll switch us back to acrylic here. Let me just go back down to 1/4" aluminum. So now it's showing me that for 1/4" aluminum, we're at 46.1 inches per minute. So that's fairly typical. If you go from a 1030 nozzle combination with a 30 horsepower pump to a 50 horsepower pump with a 1440, you'll see about a 40% or so increase in the speeds. Now, if you decide that you're going to change, you're going to run your pump at a lower pressure, or you're going to run more or less abrasive, let's just remember this number right now, 46.13. If we go back into our machine database, and we'll go back to our 1440 machine, and we change this and say, all right, we're going to run at 55,000 PSI now. Anytime you change something like that, the abrasive flow rate, the pressure, nozzle orifice size, click on Recalculate Material Values, and then click on Save and Exit. And then if you go back into that material database, we'll just switch to the 1440 up here now, and go back to our aluminum 1/4" database, material database. And you'll see here it's gone down to 48.5 inches just by changing that pressure. So if you do ever change the pressure on your pump, your abrasive flow rate, you can go into that machine database, make your changes accordingly, click on Recalculate Material Values, and then it'll adjust the feed rates accordingly. All right, look at a couple more things in the material database. There's a lot of stuff to look at in here. So we were again earlier looking at the leads tab. So if we work from the bottom here, work from the top down, that would make more sense. First of all, you have choices of whether a material is fragile or not. So for example, if we look at glass, go down, find some glass here, click on glass. Glass, you're normally going to set this button to fragile. And if WARDCAM sees that, then it's going to tell the pump to go into low pressure. And it also applies a circular pierce on each of those pierce points. So at low pressure, it'll go around, make circular pierces at each of the pierce points, and then the pump will go up into high pressure, and it'll come back and pierce through those areas where it did its pre-piercing and continue on normally from there. So that's what that button is there. So if we go back to our aluminum, if you do turn this on, you'll see that this here goes from saying use circular lead to use low pressure circular lead. So that's what clues in WARDCAM that you want to have the pump go into low pressure when it's doing those pierces. And here, yes, you have your option to do circular lead-ins or circular pierces. So if it's really thick material, you need more length of lead-in, and you don't want to have a 1/2 inch or 1 inch long lead-in. Rather than doing a 1 inch long lead-in, you can tell it that you want to use a circular lead, and then it'll make a little circular piercing motion, pierce through, and then you can have a very short lead-in length. So that's the way you can pierce a little bit with a shorter lead-in length and nest your parts a little bit closer together on thicker material. So 1/4 inch, I'd probably just go without the circular lead. And then you can also choose whether you want to arc in and arc out for your lead in and lead out. So if I did have a lead out length here, which I don't, but I can give myself a little bit of a lead out length, and then choose whether I want to arc in and arc out for my lead ins and lead outs. And you can do that for inside, outside cuts and the other. So we'll set this back to 0. So tab width, if it's an inside cut, if you put a negative number in here, then that'll tell the jet to cut past where it let in by whatever this number is here. So if it's a positive number, like on the outside, it's going to leave a gap, start short, so the part won't fall into the tank. And if it's a negative number, then it'll cut past where it let in. And then your length of lead in, if you do want to have lead out, specify that, the angle that you want to lead in and out at, so you can adjust those accordingly. And right now this is turned on, but normally when you first come in here, this advanced button is turned off. And if you click on it, then things like that angle of lead in and such will show up. The other thing that shows up when you turn on the advanced button are the ramping and the marking and the other tabs, which we'll get to here in a little bit. So I think that covers the leads tab. And if I go over to the feed rates tab, so feed rates, again, we've got our material name, we've got our thickness. If you do want to make a new thickness of material, so I want to do some 2-inch aluminum. So most of the materials will go up to 1 inch, but it's very easy to add a material beyond that. You just highlight, I usually highlight the thickest one I've got here, click on add material. Again, it'll make a duplicate entry of that. And then you come up to the thickness area, type in your new thickness, and then we'll click on the calculate button. If you don't click on the calculate button, it's still going to be the feed rates for the 1 inch. So you always want to make sure you click on calculate, and you'll see that these feed rates will adjust based on the thickness. The other thing that it's using to calculate those feed rates is this machinability number. So if the number is greater than 1, then it's going to cut faster than steel, and if it's less than 1, it's going to cut slower than steel. So this is telling us that we're basically cutting 2.9 times faster than steel. If you go down to, say, titanium, titanium is 1.5 times steel. Steel, of course, is set to 1. Stainless, you can either set it to like 0.8 or 0.9. I usually find that actually 0.9 works pretty well for that. So you've got your machinability number there. Again, if you've got some harder material, you can just come in here, change it, click on calculate, and the feed rates will adjust accordingly. Usually the question comes up is how do I add a entirely different material that's not in my database? So our training classes always give the example of somebody comes to you with a piece of kryptonite, and that's not in our database. First thing that you would do typically with a material that's you're not familiar with is actually bring it out your Waterjet, and you would do a series of test cuts at some different speeds so that you can basically determine what you want to call the Q5 or the smoothest speed, and the medium or Q3 and the rough or coarse speed. And then based on that, then you can plug in the appropriate machinability number here. So let's say, for example, somebody gives me some kryptonite and I do some cuts out there, and it's 1/4 inch kryptonite. So what I'm going to do is I'm going to take my 1/4 inch aluminum here again, and I'm just going to click on add material to make a copy of that. So now I've got 2 1/4 inch aluminums, and one of them I'm just going to rename as kryptonite. And it is 1/4 inch, and based on my test cuts, I determine that what I'm going to call my normal speed, I want that to be somewhere around 10 inches a minute. So if I put in just machinability of 1, that's going to bring it down to 15.9. So I want to be about 2/3 of that or so. So let's try 0.6. And we're at 9.5. We'll try 0.7, 11.1, 0.65. So you can just play with this machinability number until you get this number to where you want it. And then that'll also calculate the other feed rates. So that's pretty close there. So then we've got 6.4 for our smoothest, 16.9. If you do want to manually go in, you can just manually go in and change numbers. So if you want that smoothest to actually be a little bit slower, faster, you can just go in and change a number. That's why there's this locked button where you do change something. You don't want somebody to inadvertently come in here and click on the calculate button. If you click on this locked button, you click on calculate, it's not going to change these feed rates. Of course, it is pretty simple. If somebody just comes in here and clicks on the locked button again, they can click on calculate, it'll reset it, but at least it's keeps it a little bit from people being able to just click on calculate and change all your feeds. So there's your machinability number, and then for each speed setting, quality setting, you've got a high speed and a low speed. So high speed is, of course, what we try to get up to on any line segment or arc that's big enough, and then your low speed is what you're going to slow down to on any corner. So we'll always go down to the low speed, and based on the line segment, may or may not be able to get up to the high speed. So that's the feed rates tab. And again, as long as this advanced button is turned on, then you'll also see the ramping tabs. So ramping, you can tell it distance that you want to accelerate, or coming out of a corner, distance you want to accelerate coming out of a corner and going into a corner. So normally these ramping numbers are pretty good, but if you do want to adjust these, this is where you can adjust that. So you can tell it the distance that you want to start ramping down from the corner, and then how many lines of code that you want to use to ramp up or down. So generally what you'll do is you get thicker, you'll want to give yourself more distance to ramp up and down, and you'll want to give yourself more steps. So on this 2-inch aluminum that I created here, I might go through in just 5 steps, and maybe as we go faster, give ourselves more steps, and then if you need to, you can adjust your distance. So that's the ramping tab. Marking tab is if you do have geometries that you just want to etch with the WaterJet. This is where you can tell it what feed rate that you want to use to do any etching at. If you want to have any dwell when it first turns the water and or abrasive on, which normally people don't want that, or you want it to be just very short because you don't want to get a big divot where the water and the abrasive turn on. And then you can tell it for the marking whether you do want to use abrasive and whether you want to do that marking at low pressure or high pressure. So those are the basic parameters that you can adjust if you do want to do marking, your feed rate, whether you want to use abrasive or not, and whether you want to do it at low or high pressure. So of course, as you get into thinner materials, you probably less and less want to use abrasive or adjust your feed rate high enough so you don't actually cut through the material. So normally people are doing marking, they'll do it at low pressure, usually without abrasive. So you've got those parameters you can adjust for marking. And then on the other tab, you've got things that control the feed rate on your lead-ins. So we do our lead-ins at a slower speed than we're actually going to cut our geometry at, and that's just to make sure that we've got enough time for the water and the abrasive stream to establish itself and pierce through the material before we actually get to the geometry. So usually on thinner materials, 1/4 inch and under, I'll usually actually drop this down from the default, especially when you get into like 1/8 inch and thinner. I find that WARDCAM at 50% takes off a little bit too quickly, so I'll usually go through and on my thinner materials, I'll usually set these lead-in feed rates to 25%. Lead-out feed rates, so we slow down for the lead-out. 30% I've found is fine for that. If you are doing circular piercing on glass or thicker material, you can define the diameter of circular piercing that you want to make, and then how many circles that it's going to make when it is making that circular piercing move. If you're just piercing a point, like we were on that first point, how long you want to sit there to do the pierce, so you can adjust that. If it's thicker material, you want to make sure you get through, you can adjust that accordingly. And then dB material blowout distance. This one here I'll show you an example of here in a moment. Basically, if you got material that it might, at the pierce, it might delaminate, you can basically, this is telling WARDCAM that's not going to put a lead pierce point within this distance from another part in case there is any delamination. So customer emailed me over a file the other day that gives a good example of that, show you how that can be used. So there's our setup for our new quarter-inch kryptonite. Now, the nice thing about having used the machinability number to set up this quarter-inch kryptonite is if next month a customer comes to me, now they've got a piece of half-inch kryptonite, I can just highlight what I've got, click on Add Material. Again, it'll make a copy of that quarter-inch one, and then I can go to one of these and change the thickness, and then since I've already got my machinability, I can just click on calculate and it'll adjust the feed rates accordingly. So that's quite handy. And we'll click on save and exit. All right, so we're gonna go ahead and we're gonna cut this out of our quarter-inch kryptonite. Again, click on our next button, click on our auto button, puts our toolpath on there. If you do wanna, again, change our lead, so I'd probably want to put my lead on this corner here. Now, since I've got a tab, WARDCAM wants to basically always lead in at 90 degrees. On this corner here, I probably want to lead straight in and lead straight out. So because I've got the tab, it wants to do what it's doing there. So to avoid that, what you can do is if you set your tab width to 0, click on save and exit. So I adjust my outside tab width to 0, save and exit. So now when I click on that corner, it'll lead straight in. And then if I wanted to give myself a little bit of lead out to make sure I cut across there, that should be plenty. Save and exit. So that's how you can put a straight line lead in, lead out on a corner. Now, what if you actually want a tab on that corner? The way to do that at this point would be go back into our edit leads. So put in my tab width, but now change my angle, in and out angles to 0, save and exit. And now when I put the lead on here, I can basically kind of have to move my mouse around, but basically, what I should have done, of course, sorry, go back in here, is not have any lead out length. That defeats the purpose of the tab width. And click that on there. So now you can put your lead on the corner and have a straight line lead in into the corner as well as have a tab. So that's how I would finesse that. So if you want a tab on a corner, put the tab width in, out length to 0, set your in and out angles to 0, and that'll do that. All right, and from this point here, again, I could just do my fast forward button, create my CNC file, and create my report. Now, if you don't care about seeing the CNC file every time, you don't generate the port, if you go up to this options area on this last screen here, you've got these check boxes, and you can turn these off. So if you don't care about seeing the reports, you don't care about seeing the CNC file, just uncheck those, click on the CNC button, or you click on the fast forward button, and it'll go through and make the files accordingly, but won't actually display them to you. Also on this options tab is this edit variables area. Click on this, and this allows you to adjust different things that affect the way that the Waterjet's going to behave. So for example, if you scroll all the way over to this Waterjet tab, we've got our codes that we use for our water and abrasive on and off. So we can use WARDCAM typically to create code for other people's machines. So if your machine is using M04 for abrasive on and M03 abrasive off or whatever, we can adjust those. So let me get these back the way they were. And then there are other things you can do in here. You can change your delays after water on, delays after abrasive on, things like that. One change that I always like to make on a new installation of WARDCAM is this dwell after water on. by default when you first install WARDCAM. This is always set to 0.5. However, I find that we actually don't want any delay between the water on and the abrasive on. We want both of those things to turn on at the same time. So I usually recommend setting this dwell after water on to 0 so that those turn on simultaneously. And then you've got things in here that if you are doing circular piercing, you can have it make extra circular turns to make sure that it pierces through the codes that we use to tell the pump to go into low and high pressure, things like that. So if you want to change the way that code is behaving, it's usually going to be a setting in here that you can adjust. Right now I've got a whole bunch of different tabs that are available up here, and that's because on the beginning of this webinar, I turned on my scroll lock key. So if I press my scroll lock key again and click on this options button, go into edit variables, this is normally how you're going to see it. So there are fewer tabs in here. And let me exit out here again. So if your keyboard does not have a scroll lock key, then you just need to go into your Windows command bar and type in on-screen keyboard. And because a lot of keyboards nowadays don't have the scroll lock key, so if you have your on-screen keyboard, you can press scroll lock, and then that will show you those different options up here. So if you go to options, edit variables again, it'll show all the different tabs. And then also what you can do is you can make tabs disappear. If you turn off all of the buttons on a tab, so this machine is not a 5-axis machine, so if I go through and I turn off all of the things on the 5-axis tab, then when I turn off my scroll lock, then that 5-axis tab will no longer show up. Or if there's just a tab that you don't want somebody else getting into, you can do this, turn them all off, save and exit, and then if I go back, turn my scroll lock key off, and go back into edit variables, now that 5-axis tab is gone. So that's a handy thing. And also one thing that you usually will have to change for newer machines, if you go onto this machine tab, because we always used to do our 0 points lower right-hand corner of our machines, and now we've changed more to lower left-hand corner. If you set this machine rotation number to 0, then it'll give you your parts in the proper rotation when you actually send them out to the machine. So I've just got a few more minutes left here. So let me just show you the one file that was kind of interesting that a customer sent me the other day. So let's open up this one here. So we've got a bunch of these rings here that they wanted to cut, and we'll stick with a 1/4-inch kryptonite, although let me check my material settings to see if they're similar to what they had set up. I think they were using 0.5 for their lead-in length. And hit our next button and click on auto. And let's see, that wasn't quite how it was happening. Oh, because I changed my angle of lead-in. Turn on my advanced button. Let's put these back on 90 and 90 how they were originally. Click on auto again here. All right, so yeah, so this is how it was. So WARDCAM was basically putting the leads, so they're pretty much getting their pierce point from the other part into the part that was adjacent to it. And this is where we utilize the material, go into the material database and click on my advanced tab, go into other. And if I adjust this dB material blowout distance to something like 1/4 inch, save and exit, and click on auto again, you'll see that those lead positions will move away from that other part a bit. So that's one area where you can use that field. If you want to move your lead point, your pierce point away from other parts, you can adjust that. So pretty much used up my hour here. I have been recording this, so we will send out a link after the meeting so you can review this. Let me just see if we've got some questions here. Yeah, so if you go into there's a question as far as the velocities, speeds. If you go into our machine database, we do have machines that traverse at higher speeds now. So if you have one of our linear drive machines or such, or you have a machine that rapids at a faster speed, you can go ahead and you can set this up to the actual maximum machine velocity, and that's used when it calculates those cutting speeds on the reports. Let's see. I don't have the options tab. Is there somewhere to enable it? Let's see. Options. Hold on. Oops. Let's see. Options tab. So if we come up here, options, edit variables, and then you'll come into this area here. Now, if there's a tab that's not visible, then again, if you save and exit, hit on our scroll lock key and then go back into options. So this options is always available just on the post screen. You have to be on the post screen to see this options, and then edit variables, and then you would see all the different tabs that are available here. So this is only available when you're on the post screen. If that didn't answer your question, let me know. And yes, all of our machines come standard with 2 copies of WARDCAM, one that's loaded on the controller, one that's an offline copy. So anybody that buys a WARDJet machine is going to get WARDCAM. If you have, again, somebody else's machine, company XYZ, and they run G&M code, then you could purchase a seat of WARDCAM and program your machine for off of WARDCAM. And I believe the first seat of WARDCAM is like $2,350, and then additional seats are $295. So, hope that was somewhat entertaining and informative for you all. Thanks for attending, and we'll probably do this again next month. If there's some topics that I brushed over too quickly or you want me to go into more depth on, let me know, and appreciate your time and interest, and have a great weekend.